Assalamu alaikum, dear students. Today our topic is phosphorus allotropic forms. Phosphorus is a reactive non-metal. It does not exist in the free state. It forms exists in different allotropic forms. But the main allotropic forms of phosphorus are: number one, white phosphorus. Number second, red phosphorus. And number third, black phosphorus. Now we will discuss these one by one, and the first one is white phosphorus. White phosphorus, it is translucent, white, waxy solid, insoluble in water, but soluble in carbon disulfide. It's poisonous in nature. It glows in dark. It has low ignition temperature. Of 300 Kelvin, due to which it burns in air. Forming phosphorus pentoxide. So P4 plus O2 forms P4O10. This is 5 times this phosphorus pentoxide. This phosphorus pentoxide, actually it is a solid, and it is formula, actually the formula of the phosphorus pentoxide is P2O5. Here it is formed the dimer as P4O10. It is always kept in water. It is less stable and more reactive than other solid phases due to angular at normal condition. Due to angular strain in P4 molecule, where bond angle is 60 degrees. In P4, each phosphorus lies at the corner of a regular tetrahedron with P angle PPP is equal to 60 degree. So its structure is like this. This phosphorus is lie at the corner of the regular tetrahedron and the PPP angle is equal to 60 degree. On exposure to light, it turns yellow. So it is also called yellow phosphorus. So this is all about the white phosphorus, that it is translucent, it is insoluble in water, it is soluble in carbon dioxide, it is poisonous in nature, it glows in the dark, it has low ignition temperature due to which it burns in the air and forms phosphorus pentaoxide. It is always kept in the water, it is less stable, more reactive than other solid phases at normal conditions due to the angular, this is the angular strain in the P4 molecule, that each PPP angle is inclined at an angle of 60 degree. In P4, each phosphorus atom lies at the corner of the tetrahedron, so it is tetrahedral in shape. Tetrahedral in shape. On exposure to light, it turns yellow, so it is also called yellow phosphorus. Now we will take a red phosphorus. Then this white phosphorus, number second, a red phosphorus. When this white phosphorus is heated to 573 Kelvin in an inert atmosphere of the carbon dioxide or the coal gas for several hours or the several days, we get red phosphorus. So this is white phosphorus. When it is heated to 573 Kelvin in an inert atmosphere, like we will take it in the presence of carbon dioxide or coal gas, in absence of the air, we heat it for several days or several hours, it is converted into red phosphorus. Like white phosphorus, the red phosphorus, P4 molecule in the red phosphorus exists in, it also exists in the P4 tetrahedral. In red phosphorus, P4 molecule, like red phosphorus, it exists as P4 tetrahedral, but these are joined together by a covalent bond and therefore these form polymeric structure. So the polymeric structure of this is like this. We have phosphorus, 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 sorry, this, phosphorus, phosphorus, phosphorus. Similarly, it is linked with other phosphorus, 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 phosphorus. This is like this, and this is linked to other. This is a bond between the phosphorus. So another molecule here like this, P, 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 P. This is the polymeric structure of tetrahedral structure of a red phosphorus. In which each P4 molecule, again the phosphorus in the P4 molecules are linked by the covalent bonds, and one P4 molecule is linked to the other by the covalent bond. So this is the polymeric tetrahedral structure of the red phosphorus. It is non-poisonous. Insoluble in water, and carbon disulfide. Due to its polymeric structure, it has very high melting point as compared to that of the white phosphorus, and it is relatively more stable and less reactive than white phosphorus. So this is all about red phosphorus. Now we will take the black phosphorus. Number 3 is black phosphorus. This black phosphorus exists in two forms. Number 1 is alpha black phosphorus. Number 2 is beta black phosphorus. Now first we will take alpha black phosphorus. This alpha black phosphorus is obtained by heating red phosphorus. We will take red phosphorus and red phosphorus and on heating to 803 Kelvin, when the red phosphorus is heated to 803 Kelvin, we get alpha black phosphorus. We heat it in a sealed tube. In a sealed tube, we get P4, that is alpha black phosphorus, it sublimes in air, and when it sublimes in air, it changes directly from solid to the gaseous stage. It has opaque monoclinic or rhombohedral crystals. And one more property is that it does not get oxidized. It does not get oxidized in air. It does not get oxidized in air. This is all about alpha black phosphorus, that we get this alpha black phosphorus when the red phosphorus is sealed in a sealed container, in a sealed tube at 803 Kelvin. So we get this alpha black phosphorus. This alpha black phosphorus does not get oxidized in the air. It has opaque, not transparent or translucent, but opaque monoclinic or rhombohedral crystals, and does not get oxidized. And now the last one is beta black phosphorus. So beta black phosphorus. This beta black phosphorus is obtained when we heat, by heating white phosphorus So when white phosphorus is heated to 473 Kelvin under pressure, we get beta black phosphorus. This beta black phosphorus, beta black phosphorus is similar to that of the graphite, and it does not get oxidized when it is heated up to 673 Kelvin. It does not burn up to 673 Kelvin. तो 673 Kelvin तक जब इसको हीट दिया जाता है up to the 673, it does not burn, so it does not get oxidized, burn to get oxidized. So when it is heated more than 673 Kelvin, it then burns. This is all about black phosphorus. Now we have the compounds of phosphorus. And the compounds of the phosphorus compounds of phosphorus. So in the compounds of the phosphorus halides, we will take phosphorus halides. phosphorus reacts with the halogens and form two types of the halides, that is Px3 and Px5. In Px3, where X is the halogen, it can be fluorine, chlorine, bromine and iodine. And in Px5, X is fluorine, chlorine and bromine. So these are the compounds formed by the phosphorus when it fights with the halogens. Now in the phosphorus trihalides, this is Px3 is phosphorus trihalide and this is phosphorus pentahalide. In phosphorus trihalide, we will take the general formula is Px3, while X represents the halogen, fluorine, chlorine, bromine and iodine, and in the phosphorus pentahalide, Px5 is X is the halogen, fluorine, chlorine and bromine. Now in the phosphorus trihalide, we will take Pcl3 and we will see how it is prepared. Phosphorus trichloride. It is prepared by the action of dry chlorine on white phosphorus. By first method of preparation is by the action of dry chlorine on white phosphorus. So P4 plus chlorine, it forms PCl3. We will take it 4 times 12. This is 6 times. So when phosphorus, white phosphorus treated with the chlorine, it forms phosphorus trichloride. Second is by the action of or by the reaction of thionyl chloride with chlorine, with phosphorus, white phosphorus. So P4 plus SOCl2, this is thionyl chloride, it forms PCl3 and it forms PCl3 SO2 plus S2Cl2. So we will balance it P4 and we will take 8 times and we will take 4 times and 2 times. You will see P4 PCl3, that is 4 times. The phosphorus 4 times, 12 times Cl2. We have 8 times S, 4 times S, 2 to 4 times S, oxygen 8 times, 2 2s are 8 and chlorine 16 times, 2 2s are 4, 4 or 12, 16. This is sulfur dioxide, this is sulfur monochloride. These are the two methods of the preparation of the phosphorus trichloride, and now properties. This phosphorus trichloride gets hydrolyzed in moist air, hydrolysis. It gets hydrolyzed in moist air. So Pcl3 plus water, it forms, when Pcl3 reacts with the water, it forms a compound that is H3PO3 and HCl is formed. H3PO3 plus HCl. So H3 we will take this 3 timers, so H3 3 timers, hydrogen 6 timers, phosphorus 1 time. This is phosphorus acid. So when the phosphorus trichloride is hydrolyzed in presence of moist air, it forms phosphorus acid and hydrogen chloride. Now the second property is that it reacts with the compounds and replaces containing the OH group. Number second property, it reacts with compounds containing hydroxyl group. I carboxylic acid like CH3COH and alcohols like C2H5OH, replacing their OH group by Cl. So we will write the reaction. CH3COOH plus PCl3 forms CH3COCl thrice CH3COCl plus H3PO3. This is CH3COO 3 times Cl, तो 3 times, तो यहाँ पर रह गया P1 और हाइड्रोजन 3 Cl3, हाइड्रोजन 3 फास्फोरस 1 और ऑक्सीजन CH3COCl, CO यहाँ से ये OH रहता है, तो 3 times हाइड्रोजन और 3 times ऑक्सीजन, 3 times ऑक्सीजन and 3 times. This is phosphorus acid. And this is acetyl chloride or acid chloride. Again with CH3, C2H5, OH plus PCl3, phosphorus trichloride, it forms C2H5Cl thrice plus H3PO3, ethyl chloride. Now this phosphorus trichloride, it is a oily, it is a colorless oily liquid. Its structure is like this. It has a pyramidal structure. Phosphorus trichloride is this is Cl and Cl, this lone pair of the electron. This is pyramidal structure. So this is all about the phosphorus trichloride, and in the next we will see phosphorus pentachloride, next topic, next lecture. So this is for today, the compound of the phosphorus, that is phosphorus trichloride, and also we have discussed the allotropic forms of the phosphorus, that is white, red and black phosphorus.